610, the last lesson in chapter 6. Today we're going to be talking about using sampling to predict. So basically, if you wanted to figure out how people felt about your new movie that you made, you would not be able to literally ask every single person. So basically what you have to do to be able to predict some sort of information, you need to take what's called a sample. A sample is a smaller group of selected from a larger group. So basically that you're taking a random group and you're going to ask them a question and you're going to get some feedback, and overall the selection that you have chosen or the sample that you have chosen should give you an overall feel of how everyone feels about it. So there are basically several different ways of doing this. The first way is, we have three different ways of unbiased samples. So basically an unbiased sample is, it represents a larger population, it's selected at random without preference, and it is large enough to provide accurate data. So you can't only choose like 5 people, because I won't tell you how everyone felt. One of those 5 people still happen to be friends and they all have the same opinion, and so you won't have a good view of what everybody thought. So there are 3 different types of unbiased samples. Now in this lesson you're going to have to be able to tell me, is it simple, is it systematic? You're going to have to be able to tell me those things. So we need to make sure to know these definitions pretty well, because you're going to have to really pick out just one little key word that lets you know that it's this one instead of this one. So basically let's start with the simple unbiased sample. It's anyone is likely to be chosen. So it could be anybody. So basically an example of this would be if a computer chooses random ID numbers. So literally you just said choose 30 random people, then the computer would do that. So obviously the computer has no preference of anything. Even if you were trying to choose 30 people, it would be like you might choose certain people over others for some reason. So that would be a reason why it would be unbiased if the computer randomly selected. Another type of unbiased sample is stratified. It is a sample that is divided into groups, and some are chosen from each group. So basically, you have a random group of people, and they are separated into groups, and you take a few from each of those groups. So for example, 5 students are chosen with birthdays from some months. So basically, that you have this group of people, and you're separating by their birthdays. So many people are in January, so many people are in February, so many people are in March. And then you go ahead and you take 5 random people from each of those months to be able to ask a question or to get some data for something. The third different type of unbiased sample is systematic, and it is a sample of selected in time intervals. So systematic brings in time. So it says, like if you had a game going on or some sort of like prize, and you said the 100th caller will get this prize, so basically after so many people that person will get a prize. So it'll be random because you won't know who it was. Not even the people who are trying to call will know who's the 100th caller. So it's completely random. Another example would be like if every 20 minutes a winner will be drawn from the raffle or something like that. So it has to do with time or a certain type of interval. So simple, we have literally anybody can be chosen. Stratified is like we are dividing them into groups, and then we're going to take a few from each group, random people. And then systematic has to do with time or intervals. Alright, let's go ahead and look at some other examples. Let's continue to look at some more notes. So on the last screen, we were looking at unbiased samples. So that is what you want if you really want to get some accurate data or a good representation of what everyone thinks. But if you have a biased sample, then obviously you're not going to get the views of like the whole population. So unbiased or biased sample is a sample that doesn't represent the population. So if it doesn't represent the population, why are you doing that survey with that people anyways? It's really pointless. So we really want to do unbiased samples. But different types of biased samples, so if you're trying to see if the information is valid or not, you're going to have to look for these things to see if it's not valid. So the first type of biased sample is convenience. So basically a sample that is easily accessed. So if you said the council surveys residents within 1 mile of a park about the changes to the park. So basically, okay, well, let's just talk to these people that live close to us. Is that going to give you an accurate representation? No, because you're hand choosing who you want to survey. B is voluntary. So it says the sample includes volunteers only. So So an example would be the school board emails the seniors asking for volunteers to complete a survey about where to hold commencement. So basically voluntary isn't very accurate because how about if a whole group of friends went ahead and volunteered and that had most of the people were just friends? Then they could have like the same opinions on things and things like that and all vote to kind of push something through. So sometimes voluntary isn't the most accurate means of sampling. Alright, let's go ahead and try to pick out some samples ourselves. Let's look at a few examples. Number 1, it says to determine which passengers' carry-on bags are to be inspected, every 8th person to receive a boarding pass will have his or her bags checked. So basically what we want to do is look at this information and say, is it valid or not? Is it biased or unbiased? And what type of biased or unbiased sample is this? So basically, first of all, I see that we're talking about every 8th person. So that's kind of the part that stands out to me. So I see that it's like every 8 people, we're going to check. Every 8 people, we're going to check. Every 8 people, we're going to check. So that is, to me, that looks like we're having a systematic sample going on. So to me, this is, yes, it's valid. It is unbiased. And it is the systematic. Because the good thing about that, unless you literally placed a special person in every 8th person, then it's going to be random, completely random, so you're going to get a good sample. Number 2, it says to determine the favorite sport, 30 people at a football game are surveyed. So first of all, I'm saying that we're looking for the favorite sport. And then we're surveying 30 random people at a football game. Maybe our random people are 30 people are random, but we're talking about at a football game. So what sport do you think is going to be their favorite? Football? So to me, this is not valid at all. So it's not valid. This is biased. And it's since we're all at one game, you're just surveying people in your one little area, I would say it's convenience because you don't have to go very far. You're already at the game, so you're just going to ask those people at the game what their favorite sport is. This would be if you're trying to do a project for school and you're taking the easy way out. That's this one. So this is the convenience. Alright, number 3. Of the 2,000 watches produced, the manufacturer tests the first 15 watches produced for defects. 3 were defective. So is this valid or not? So first of all, I'm thinking, okay, we're having 2,000 watches being produced. So they're all being produced and being produced. And so he goes ahead and takes the first 15. Do you think that that is a very good sample? I wonder if the machine messes up later on in the whole run. So I would say that that's not very valid. You want to take some random ones out of all of them. Maybe a systematic approach, like every 5 of them check. Or every something like that. That would be a better check to make sure, well, is anything wrong with the machine as we're going on? Or does something happen along the way? So I would say that this is not very effective. And so it's biased. And this is one of those ones just like this one. It's convenient. So you're just taking literally the first ones there. So that's convenient. We don't want convenience if we actually want results here. If you're going to do a survey or if you're going to do some sort of check, you want to make it count. Alright, number 4, it says every 5th person that left a restaurant was surveyed about whether or not they ordered dessert. Out of 20 people, 12 said yes. So basically we're having every 5 people we're going to check. Every 5 people we're going to check. Every 5 people we're going to check. So this looks like it's a systematic, and that is biased or unbiased. So we're saying yes, this is valid, because you're checking pretty often and you're checking random people. So this is yes, it's unbiased, and it is systematic because we're doing it every so often or every, like you have a planned amount of time that you're going to ask somebody. So this is if you would like to see a few more examples, you can go ahead and look in your textbook. There are some that are already done for you, and maybe you could see some different examples that aren't these 2 different types, alright? So now let's go ahead and do some on your own questions. Alright, you have 3 problems to do for me. For numbers 1, 2, and 3, you need to go ahead and tell me whether or not the information is valid, biased, or unbiased, and which type. So number 1, it says, To determine how many students at a middle school bring their lunch from home, all the students on one school bus are surveyed. Number 2, it says to determine the theme for the homecoming dance, the homecoming committee surveys one classroom. And number 3 says to determine shopping habits at a department store, one female and one male shopper are randomly selected and surveyed from each of their 75 stores. All right, good luck. We'll see what you get tomorrow.